Similarity theorems. Let's dive right in. So first thing that we're going to look at is we're going to review what our different triangle similarity theorems are. There's 3 of them. Then we're going to have 2 sets of triangles, and we're going to try to say, do we have enough information to say that those triangles are similar to each other? And then lastly, we're going to do a proof that's going to have a triangle similarity theorem in it. So first things first, what we have here is angle, angle. So on this, if you have 2 triangles right here, and in those 2 triangles, there's 2 sets of congruent corresponding angles, then that's enough to show that those triangles are similar. So that's all we would need for that. Side, side, side is basically saying if the measures are proportional. So if I set up a proportion and I say 1 over 1, 2 over 2, and then 3 over 3, if I set those up and those sides are all proportional to each other, then that is enough to show that those are similar triangles. If you need a review on proportions, I have a video on my channel. Please look back at that. Last is side, angle, side. And so if I've got 2 sets of triangles here and 1 and 1 are proportional and 2 and 2 are proportional. So if I've got 2 sets of proportional sides and then the angle that's included or in between those angles, if those angles are congruent, then that's enough to show that they're similar. All right. So let's take a look at this in action. So this first one that we've got here. So I have 1 set of congruent angles. Well, what angle is that? If I look at this in this triangle right here, angle A is going to be congruent to angle A in this triangle right here. So angle A is congruent to angle A. So I've got 1 set of congruent angles. Now, proportional sides. I've got 2 sets of side measures here. So this side is 9. This whole side here is 9 plus 3, so it gives me 12. So that's what this side is. Over here, this side's 12. This side is 12 plus 5. So that means that this side here is going to be 17. If I set up my proportion, 9 over, well, let's do it down here. 9 over 12 is equal to 12 over 17. If I plug those in my calculator, I'm going to get that those don't equal each other. So because of that, I don't have any proportional sides. Well, 1 congruent angle isn't enough. So I would say that this is not similar. That little squiggly just means similar. All right, next one. So what we've got here. First, identify any congruent angles. So I've got this angle is congruent to this. I also have this angle is congruent to this. And really right there, that's enough information that I need. I've got 2 sets of congruent angles. I don't have any side measures, so I can't say that anything's proportional. But because I have 2 sets of congruent angles, I can say that the angle-angle similarity theorem is enough to show that those triangles are congruent. All right, next one that I've got right here. So on this, identify any congruent angles. I don't have any congruent angles. So since I don't have any congruent angles, I've got that. Set up my proportions, 12 over 18, 12 over 18, 12 over 18. Those are my 3 sets of proportions that I have there. While all of those would kind of reduce down to 2/3. That's that scale, the similarity scale that you have, or the scale ratio that you'd have. And so those, I'd have 3 sets of proportional sides. Well, when you have 3 sets of proportional sides, that's the side, side, side similarity theorem. And so that is enough to show that those are similar. All right, let's take a look at this proof. So I've got 2 triangles, triangle HEI and triangle HFG. I'm given that this side here, IE, is going to be parallel to this side. So that's my given information. So I can always write that down. Always start with your given. Now, first thing that I've got here, angle H in this triangle is going to be congruent to angle H in this triangle. What allows me to say that? Well, I can always say that because of the reflexive property. So reflexive property is what will allow me to say that. Next, I've got that this angle right here is congruent to this angle right here. Remember back when we had 2 parallel lines cut by a transversal, we said these angles were congruent because they are in the same spot. That is that corresponding angles postulate. So we would say corresponding angles postulate. That's what allows me to be able to say that angle HEI is congruent to HFG. All right, now, angle-angle similarity theorem. Well, I've got 2 triangles, and so I just need to name those triangles. So triangle HEI is going to be similar to triangle HFG. So that means those 2 triangles are going to be similar to each other. Therefore, I know that if they're similar, then I know that those side lengths are going to be proportional. So I would say that that's just the definition of similar triangles.